Hello everyone, this is Bindu Kumar here. Let's solve this question together. For what value of n are the nth terms of two arithmetic progressions 63, 65, 67 and 3, 10, 17 is equal? Okay, so this question is a bit confusing, so let me explain. First, it is being said that there are two arithmetic progressions, which is 63, 65, 67 and 3, 10, 17. If they say it is an arithmetic progression, it means the terms have a common difference d, which is already established. Okay, so they're saying there are two arithmetic progressions. Now, for what value of n, meaning we have to find the nth term in both these arithmetic progressions where the values will match. Let's write this down. So the first arithmetic progression, let's call it A. We have numbers 63, 65, 67 and so on. We have the next arithmetic progression B, represented by 3, 10, 17 and so on. Now these can also be represented as A of 1, A of 2, A of 3. These can be represented as B1, B2, B3. Somewhere in each of these arithmetic progression, there'll be one term. Let's call it A of n. Similarly, there'll be one term in the other arithmetic progression also called B of n. So these values will be exactly the same. They'll be equal. So we have to find what is the value of n where the values will be the same, which is the term value, which is A of n and B of n will be exactly the same. Okay, so now let's try and write down. So it's already been said that both these list of numbers are arithmetic progressions. Now what do we know about arithmetic progression? A set of numbers A1, A2, A3 is said to be an arithmetic progression if they're of the form A plus D, A plus 2D and so on. Also, the nth term can be found out by the formula A of n equals A plus n minus 1 into D. Okay, so let's use the last formula that we wrote here, A of n equal to A plus n minus 1 into D, to solve this problem. So here, let me start with the first arithmetic progression. I'll write A of n equals A plus n minus 1 into D. Now we do not know what A of n is, so I'll write A of n as this equals A. A is the same as the first term, which here is 63. So I'll write 63 plus n we do not know, and then D. D is the common difference. So D can be easily calculated just by looking at the arithmetic progression. So 67 minus 65, which will give me 2. 65 minus 63, which will also give me 2, right? So the common difference is 2 here. Okay. So similarly, let's write the formula for the second arithmetic progression also. B of n. B of n equals B plus n minus 1 into D. We do not know the value of B of n, so we'll write it as this. Then we know the value of B, which is 3 here. 3 plus n minus 1 into D. D is the common difference. Now D again can be calculated by either B3 minus B2, which will give me 7, or B2 minus B1, which will also give me 7. Okay, so we found these two equations. Now look at the question again. They're saying the nth term is equal, right? The nth term is going to be equal between these two arithmetic progression, which means a of n equals b of n. It's already established. So we can write this formula, a of n equal to b of n. Now let's substitute the values of a of n here and b of n from here. So a of n is 63 plus n minus 1 into 2 equals b of n is 3 plus n minus 1 into 7. So it gives me 63 plus 2n minus 2 equals 3 plus 7n minus 7. So we have 63 minus 2, which will give me 61 plus 2n equals, we have plus 3 and minus 7, which will give me 7n minus 4. Now let's balance this equation. I will write 61 plus 2n equals 7n minus 4. First, I would like to remove this minus 4. So I will add a plus 4 here. Now whatever we do on the right hand side should be repeated on the left hand side. So we'll add a plus 4 here as well. Also, I want to remove this 2n here. So we will add a minus 2n. Oops, sorry about that. Let me undo. Okay. So we'll add a minus 2n, and that same will be repeated on the right hand side of the equation. Now let's simplify this. Minus 4 and plus 4 cancel out each other. Plus 2n and minus 2n cancel out each other. We will have 61 plus 4 equals 7n minus, sorry, it's 7n minus 2n. Now let's continue in the next column. So 61 plus 4 is 65 equals 7n minus 2n will give me 5n. Now I want to get rid of 5, so I will divide by 5. I will balance the equation by doing the same action on the left hand side of the equation as well. So we have 5 divided by 5, which is equal to 1, and we have 5 into 1 equal to 5, and 5 into 1 and 3. So 5 into 13 equal to 65. So we get the answer n equal to 13. But let's be sure that we have found the right answer. How can we verify this? We can easily verify this by calculating a of n and b of n separately using n equal to 13. So let me do that. So I'll do it at the top here. So we have a of n equals 63 plus, now the value of n is 13, minus 1 into d. D was 2. So a of 13 equals 63 plus 12 into 2. A of 13 equals 63 plus 24. So 63 plus 24 equals 7 and 8. So A of 13 equal to 87. Similarly, let's calculate for B of n as well. So B of n equals 63 plus 12 into 2. So B of n equals 63 plus 12 into 2 equals 7 and 8. So A of 13 equal to 87. Similarly, let's calculate for B of n as well. So B of n equals 63 plus 12 into 2 equals 7 and 8. So B of n equals 63 plus 12 into 2 equals 7 and 8. So B of n equals 63 plus 12 into 2 equals 7 and 8. So B of n equals 63 plus 12 into 2 equals 7 and 8. So B of n equals 63 plus 12 into 2 equals 7 and 8. So B of n equals 63 plus 12 into 2 equals 7 and 8. So B of n equals 63 plus 12 into 2 equals 7 and 8. So B of n equals 63 plus 12 into 2 equals 7 and 8. So B of n equals 63 plus 12 into 2 equals 7 and 8. So B of n equals 63 plus 12 into 2 equals 7 and 8. So B of n equals 63 plus 12 into 2 equals 3 plus 13 minus 1 into 7. B of 13 equals 3 plus 12 into 7. B of 13 equal to 3 plus, so we have 12 into 7. 7 into 2 equal to 14, and we have 8, 84. So 84 plus 3, we get 87. So you can see the value that we got here and the value that we received here is exactly the same. Now this satisfies the question as well, which says the nth terms are equal between these two arithmetic progressions. So with this we can say the nth term or the value of n is 13, where the values for both these arithmetic progressions are equal. Thanks a lot for watching this video. I hope you find it useful. Remember to like, subscribe, and click on the bell button to get notified of new videos.